Good day. I'm going to talk to you about some of the use cases currently being explored and the international trends in artificial intelligence, RPA, and other related technologies. Data and analytics play a big role in the automation of processes. Robots love data, and the best nutritious data that you can feed to a well-oiled robot is structured data with repetitive patterns. This fits well into the type of tasks that robots are best suited to handle. Let us take a look at some of the things robots love to do. Brain-numbing tasks. Copy and paste from one application to another, Excel to UI, one screen to another, paper to system. These are the types of tasks that are not to be wished even on one's interns. People like to ease boredom with creative activity. The younger generation coming into the workforce values creativity and sees it as a path to growth, while tasks without any gray cell input is seen as a road to stagnation. When people are bored, they are more likely to make performance errors and are likely to be not as productive. Robots excel at these monotonous duties. Sensing. Robotic software connected to sensors for data input and combined with computing power, which is needed to analyze the data from sensors, helps the robots to do tasks that are beyond the human thresholds. For instance, see through walls, using thermal imaging data, spot a hidden leak of liquids or gases, hear sounds which are outside the human audible frequencies. So you can imagine a software with the five senses. Focus. So the robot will perform the task that it is programmed to do. If you want to interrupt a robot, you will have to program that too, to make it respond to events, for example. Other than that, there are no breaks, gossip, stress, work-life balance issues with robots. Perfect recall. Robotic memory is not fickle like human memories. It provides an exact log of events as they happened. Text, images, correlated data are all preserved forever in the robotic mind. This makes it an excellent tool for security agencies. There are, of course, tasks where humans will perform better. For example, anything which requires empathy, flexibility, acceptability, trust, complexity, or creativity. It is a capital mistake to theorize before one has data. I'm sure this would be a favorite quote for Marissa Myers. Famously known to take decisions based purely on data. Several years back, when the emotional decision was all about giving the employees flexibility and telecommuting was all the rage, she decided to call all Yahoo employees back to the office because the data said innovation requires people to collaborate, exchange ideas, and have fun. And how much fun can you be possibly having with yourself sitting at home? An abundance of emotion almost always indicates a lack of data. Climate change, for example. A lot of emotion, very little data. Scientific data that everybody can agree upon. Sure, something needs to be done about climate change, and we do know that the actions we can all take will reduce emissions. But without data which is admissible as evidence, it is not possible for governments to legislate businesses to scale back their growth. With the availability of more and more data, we can reduce the number of assumptions we need to make. This does not eliminate the need for judgment. It gives us something more than our intuition to make that decision. Successful business leaders make a career out of experience and intuition. Sometimes data can tell them that their intuition is off. In a lot of organizations, however, instead of using data and analytics to explore and discover, they start using it to support the conclusions they want. Let us take a look at the 4 types of data analytics we encounter in data science: descriptive, diagnostic, predictive, and prescriptive. Organizations that are not highly data-driven rely more on descriptive analytics. This type of analytics tries to make sense of huge amounts of data transactions and turn them into knowledgeable information for the executives to take business decisions. Growth in computing power today allows multiple perspectives on this data to be generated, which maybe was not possible earlier. There is a lot more that we can know from existing data, and we just need to frame the right question for the answers to emerge from the data. We need to bear in mind that all this gives us is a view of the past. Essentially, it answers the question, what happened? In healthcare, for example, a high number of ER admissions can be analyzed to find out the patient numbers by day of the week, hour of the day, and maybe give us a categorization of the nature of injuries or health issues that are being reported. Diagnostic analytics takes a deeper look into the data and tries to answer the question, why did this happen? It is also known as root cause analysis. Processes used here are data discovery, data mining, drill down, drill through. In the ER admissions example, we could take a look at the reasons for admission and find out the correlations in these reasons, which could possibly lead us to find a common infectious agent, giving us an explanation for the spike. Predictive analysis takes the historical data and feeds it into a machine learning model that considers key trends and patterns. The model is then applied to current data to predict what will happen next. In the ER example, if there is an outbreak and then there is a spread to the regions, then we can extrapolate the results to predict future admissions. Prescriptive analytics is assisted decision making. Based on the predictions, we try to come up with the possible actions that can be pursued. Each action can have further data associated to it in terms of the resources required, which will help us to prepare for the planned response. Each course of action can be associated with multiple tasks and the automated messages that need to go out to mobilize this plan into action. All of this requires sophisticated data models, algorithms, RPA, machine learning, and artificial intelligence capabilities to be present. It is obvious that this level of analytics requires machine power and is beyond the capabilities of your day-to-day tools. This is where RPA steps in. RPA started in its early days with screen scraping and has become more and more sophisticated. Screen scraping was the first technology that created a bridge between current systems and the incompatible legacy systems, and it has more recently been used to extract data from the web on the presentation layer. Data entry automation is the capturing of certain fields of interest, such as customer contact information or invoice totals, the items ordered, and translating them into your company's database. Macro recorders are simple single computer, single user applications. They're not typically used for complex operations. An application macro is a single application, but it is available for multiple users. So these can be used for scheduling reports for multiple users inside an ERP application, for example. Workflow automation, it refers to the software which notifies the corresponding employees and departments and moves the processes along, the process steps. So this kind of software eliminates the need for manual data entry and increases the order fulfillment rates. So the advantages include increased speed, efficiency, accuracy. RPA or robotic process automation is the front-end level automation, and it can be used with multiple applications and still be centrally monitored and managed. Augmented by machine learning and AI, RPA can streamline input such as the initial processing of images and documents and improve the processes through monitoring of RPA logs. RPA can help redeploy headcounts from manual and highly repetitive processes to more value-added tasks, and it can be used to improve the data quality. Artificial intelligence solves complex problems better and faster with imperfect inputs. Cognitive computing deals with the science of getting the computers to behave, think, and interact as humans do. Machine learning uses statistical techniques to give the computer systems the ability to learn, that is, progressively improve the performance on a specific task with data without being explicitly programmed. Deep learning, also known as deep structured learning or hierarchical learning methods, are based on learning data representations as opposed to task-specific algorithms. And the learning can be supervised, semi-supervised, or unsupervised. RPA and data management make a particularly compelling combination. Data management includes numerous repetitive tasks in aggregation and curation that can benefit from automation. Applying RPA to large data repositories makes tasks such as data cleansing, normalization, data wrangling, and creation or updation of metadata more efficient. All of these tasks are highly repetitive and also tend to be unique. Each data access situation demands special considerations. This provides an ideal opportunity for applying RPA. One example is the use of RPA to extract information from OCR documents to create metadata and reduce the content to a usable format for big data or machine learning processes. Other transformations of very large datasets that benefit from RPA include data input, replacing the manual keying or file submissions, migration of data between dissimilar data stores, such as data acquired from corporate acquisitions or mergers, data combinations, such as aggregation to provide richer data sources for advanced processing algorithms, screening for irregularities and improving the data quality through repetitive tasks, enabling input and verification of manual processes traditionally applied with RPA, but enhanced for larger data sources. And tasks like data deduplication and data extraction, which can be applied to new sources, new data sources like IoT machine logs and other system-generated raw data. RPA can be a powerful tool for maintaining data quality in the complex arena of big data and AI. The ability to analyze the RPA logs can help an enterprise to improve its data quality and data extraction, to determine where efficiency is lost or where processes are performing below expectations. So that brings me to the end of this first session. I hope you join me in the next video, where we'll be looking at some advanced technologies like blockchain and distributed identity management and how they can be applied to real life use cases.